Hello, my name is Kevin Walker.
And I'm David Alexander.
For our control dynamic system, we chose to discuss the use of cross-feed valves between the fuel tanks of an aircraft. These valves give pilots the ability to maintain equal weight distribution over the wingspan of the plane, and therefore help the aircraft maintain stability.
Large commercial aircraft, such as the A330, which is shown here, need plenty of fuel to travel the long distances that they travel. Fuel is stored in many tanks throughout the aircraft fuselage and wing structure. Over the course of long flights, fuel in the tanks on one side of the aircraft burn fuel faster than the other side. This can occur from many factors, such as the smallest aerodynamic deficiency on one wing, or one engine running slightly less efficiently. These tiny deficiencies will cause the engine or engines on one side of an aircraft to burn slightly more fuel than those on the other side, and therefore deplete the fuel tank on that side. After a flight of 10 hours or so, that can turn into a significant amount of weight difference from one side to the other and can cause an instability.
To combat this problem, engineers install what are called cross-feed valves. These valves can be turned on by the pilot to force fuel to flow from a more full tank to an emptier one. This will stabilize the balance of weight in the aircraft and help it maintain a steady course. The following process controls the system.
First, the pilot will flip the switch to begin fuel transfer from the more full tank to the emptier one. Each tank then provides feedback to the controller throughout the fuel transfer process, telling it how much the fuel weighs. The controller will keep the fuel valve open to allow fuel to flow until the readings sent back by the tanks are equal, meaning that there is the same amount of fuel in each tank.
This system is mainly governed by the equation for the moment about the fuselage of the aircraft. The moment is caused by the fuel flowing from one side to another. It can also be affected by the momentum equation for fuel flow. The input to the system is the pilot triggering the valve controller, and the output is the amount and weight of the fuel in each tank. Depending on the frequency of the feedback and the momentum of the fuel being transferred, some overshoot is possible, and the system could take slightly longer to stabilize.
A PID controller is often used in this instance to help control the fuel flow and stabilize the aircraft. The PID controller will keep the valve open until the amounts and weights of the fuel have been equalized and the aircraft is stable. To solve this problem, we have to consider both the aircraft-centered and the valve directional coordinate frames.
We hope you learned a little something from watching our video. Have a beautiful day.